Hi everyone, last time we did mole and molecular weight. So today we are going to discuss balancing equation, and in this video we are going to discuss the very easy way to balance any chemical equation. So this is the very first equation here. So first of all we have to assume a stochiometry like this: A, B and C in this way. Clear? And then look at the number of atom in the chemical equation. So here we have two atoms, sulfur and oxygen. So look at sulfur. How many sulfur in the left? Just one sulfur, and its stoichiometry is A. So 1 into A is just A. Now how many sulfur in the product side? Just one sulfur, and its stoichiometry is C. So we can say A is equal to C. Now similarly oxygen. Oxygen is 2 times and stoichiometry is B in the reactant, so 2B is equal to how many oxygen in the product? 3 oxygen with C stoichiometry, so we can say 3C. So once we have an equation, then look at the common factor. Common means which is present in both equation or most of the equations. So here we have C here as well as here. So the common one we can assume as 1. So let assume C is equal to 1. So if C is my 1, it means A is 1 as well. Clear? So in this case 2B is equal to 3 into 1. So B is equal to 3 by 2. Clear? So now we have A and B and C values. So we can put here A is my 1. So 1 sulfur plus how many B? B is 3 by 2, which is O2, and gives CSO3. C is what? C is my 1 SO3. So here we have a fraction, so we can eliminate the fraction if we can multiply the net equation by 2, because this is 2 here. So if we can multiply by 2, it becomes 2 sulfur plus 3 O2 to give you 2 SO3. Clear? And you can see this is 2, this is 3 and this is 2 as well. Let's check it. So 2 sulfur, 2 sulfur, 6 oxygen and 3 2s are 2, 6 oxygen. So this is the balance form of this equation. So now move to the next. N2H2 gives ammonia. So again you can assume here A, B and C. Here again we have two kind of atom, nitrogen and hydrogen. So look at nitrogen. In the reactant side we have A stoichiometry and 2 times, so 2A. In the product side we have just one nitrogen and stoichiometry is C, so just C only. Hydrogen 2B is equal to 3 into C, so 3C. So again C is my common factor, so we can assume C as 1. So if C is my 1, which means A is equal to 2A is equal to 1, so A is equal to 1 by 2 and C is 1. So let's find out B here. So 2B is equal to 3 into 1, so B is equal to 3 by 2. So once you have all the values, we can put it in the equation. So look at here, N2 A is 1 by 2, so 1 by 2 N2 plus B is my 3 by 2 H2 gives you C is just 1, so 1 ammonia. Now again we have a fraction here, so we can again multiply by 2. So the net equation we can multiply by 2. So it should be how much? N2 plus 3H2 gives you 2 ammonia, because this 2 cancel out once you multiply by 2. Clear? Makes sense? And here if you multiply by 2, it should be 2 ammonia. So let's check it. Here nitrogen is my 2, here nitrogen is my 2, here hydrogen is 6, here 3 2s are 2, 3 2s are 6, so 6 hydrogen. Makes sense? So this is the balance form of this equation. Move to the next. This is C2H2 plus O2 gives CO2 and H2O. So this is combustion reaction, okay? So again A, B, C and D. So we can say here carbon is 2 into A is equal to how many in the products? just 1, so C. Next is hydrogen. How many hydrogen? 2 into A is equal to 2D. And how many oxygen? So 2B is equal to 2C plus D. Clear? Like that. So which is common? C here, A here, A here, C common. Yes, and D is also. So here A, C and D is a most common factor. So you can assume any one as 1. So let's say suppose C is my 1. Suppose C is my 1. So if C is my 1, then A will be 1 by 2. Makes sense? So here we can say 2 into 1 by 2 is equal to 2D. So 2 cancel out. So 2D is equal to 1. So D is equal to 1 by 2 as well. We can again check. 1 by 2 cancel out. So 2D is equal to 1. So D is equal to 1 by 2. So now you can find out here. So 2B is equal to my C value is what? 1. So 2 into 1 plus what should be D? D is 1 by 2 as well. So how much? 2 plus 1 by 2. So 2 is my LCM. Okay, 2 is LCM. So 4 plus 1, 5 by 2, that is my 2B. So its B is equal to how much? 2B is equal to 5 by 2. So B is equal to 5 by 4. Clear? So we have the values. Now we can put it. So A is my 1 by 2 C2H2 plus B is how much? B 5 by 4 O2 gives C CO2. C is how much? 1 CO2 plus D is 1 by 2 H2O, 1 by 2 H2O. So look at here, we have 2, 4 and 2. So we can multiply the net equation by 4. Then we can eliminate this 4 quite easily. So simple thing is that you have to remove the fractions here. So let's multiply by 4 the net equation. So it will be how much? 2C2H2 plus 5O2 and 4CO2 and 2H2O. So let me check this. How many carbon here? 2 to the 4, 4 carbon. How many carbon here? 4 carbon, fine. How many hydrogen? 2 to the 4. And how many hydrogen? 2 to the 4. How many oxygen? 5 to the 2 to the 5, 10. And how many here? 2 into 4, 8 and plus 2, 10. So this is the balance form 2, 5, 4, 2. Makes sense? This is quite simple. Next is C2H5O2 and CO2 plus H2O. Again we can use A, B, C, D. A, B, C and D. A is suppose carbon 2A. How many carbon in the product? Only C. How many hydrogen in the left? 5 into A. And how many hydrogen here? Only D. How many oxygen in the left? 2B. How many oxygen in the right? 2C plus D. So which is my common here? D is common, C is common and A is common. So you can assume any one. Okay. Suppose A is my 1. So C is my 2. Makes sense? So D is how much? D is my 5. Why? Because A is my 1. Clear? So here 2B is equal to 2 into how much? C? C is 2 plus how much? D? D is 5. So overall 2b is equal to 2 to the 4 plus 5. How much? 9. So b is equal to 9 by 2. Clear? You can again check this. Look at here, 2a is equal to c. Suppose a is 1. So if a is 1, c is 2. So if a is 1, it means d is how much? Let me check the hydrogens. 5a and 2d. Oh sorry, I made mistake here. This is hydrogen is 2 into d. So sorry, this is 2d. 2d, sorry. Let's do this again. Hydrogen is how much? 5 into a is equal to, and here 2 into d. So a is my 1. So 2d is equal to 5 into 1. So d is equal to 5 by 2. Let's do this one as well. So 2b is equal to c is 2. So 2 into 2 plus d is how much? 5 by 2. So it should be 4 plus 5 by 2. So 2 is my LCM. So it should be 8 plus 5. 13 by 2, which is 2b. 2b is 13 by 2. So b is 13 by 4. Clear? Now we have values and we can keep it in the equation. So please put the values. So look at, a value is my 1. So 1 C2H5 plus b value is how much? 13 by 4. 13 by 4 O2 gives c is how much? C is 2. So 2 CO2 plus how much d we have? 5 by 2 H2O. 5 by 2 H2O. So again we can remove the fraction value. So we can multiply the net equation by 4. So if you multiply by 4, so how much it will be? Look at here. So 4 C2H5 plus 13 O2 gives you 8 CO2 plus 10 H2O. Clear? Let's check this. So how many carbon? 2 into 4. Carbon is 8. Carbon is how much? 8. How many hydrogen? So 5 into 4. Hydrogen is my 20. Look at hydrogen here. 2 into 10. 20. So 20H. Look at the oxygen. So 13 into 2. 26. And how much here? 2 into 8. 16 oxygen here plus 10. So overall 26 oxygen. Makes sense? So this is the most easy technique through which you can answer all these questions. Okay. So this is simple one. We can discuss another one. Look at here. The last one, H2 plus I2 HI. Simple. Take your time and tell me the answer. So please pause the video. So look at here, A, B and C. So hydrogen is in the left. So hydrogen here we have 2A, and how many hydrogen in the product side? Just C. How many oxygen here? Iodine here. So 2B is equal to C. Clear? So we have two kind of element, hydrogen and iodine. So we have this equation. C is a common factor. So assume C is equal to 1. Let C is my 1. So if C is my 1, so A is what? 1 by 2. Clear? So B is what? So 2B is equal to 1. Okay. So B is equal to 1 by 2 as well. So now we have the values and we can put it here. So 1 by 2 H2 plus B is here 1 by 2 as well. So 1 by 2 I2. Next, C is my 1. So 1 HI. So simple thing is that we can multiply the net equation by 2 to remove this fraction value. So overall it should be H2 plus Once you multiply by 2, so I2 into 2Hi. So you can check it. Hydrogen is 2, hydrogen is 2. Iodine is 2, iodine is 2. So it is a balanced form. H2 plus I2 gives 2Hi. Clear? So I discussed few examples as well, and this is the most easy way to figure out these type of questions. Thank you so much for watching this. In the next session, we will discuss limiting reagents and molecular formula and empirical formula. Thank you so much.